Hi, in this video, I want to solve an example in which we calculate net present value of a project and then we calculate internal rate of return. So let's go over the question first. So we have a project that requires investment of $8 million at the end of year 1, and the investment period continues for another 4 years. Okay, so we invest for 5 years. And these investing cash flows grow at 1.5% per year during this period. So there is a 5-year investment period and at the end of year 6, the investment is expected to begin generating cash flows of $6 million. Cash flows grow at 1.5% per year during this payout phase and continue until the end of year 15. For clarity, there is an initial 10-year phase of cash generation. Finally, beginning in year 16, the project is expected to begin generating cash flow of $3 million. This is projected to grow at 1.5% per year and continue indefinitely. If the discount rate is 9.6%, what is the net present value and internal rate of return of the project? So let's first understand the structure of the project. Here we have all the cash flows for this project. So as you saw, we have an initial investment of $8 million in year 1. So we have a cash outflow of $8 million. And then for 4 years after that, we still have to invest in this project, and the amount of investment grows at 1.5%. So cash outflow at year 2 becomes cash outflow at year 1 multiplied by 1 plus the growth rate in your cash flow, which is 1.5%. And this will continue till the end of year 5. So in order to extend this formula to other cells, first, I want to fix the growth rate, the cell that is related to the growth rate. And then I click enter. Then I extend this formula to other cells till the end of year 5. So these are cash outflows during the investment period of this project. After that, as it is mentioned in the class, in the question, at the end of year 6, the investment is expected to begin generating cash flow of $6 million. So suddenly in year 6, you have a positive cash flow of $6 million. And this cash flow will grow at 1.5% per year, and this will continue until the end of year 15. So let's calculate the cash flows. So cash flow in year 7 will be cash flow in year 6 multiplied by 1 plus your growth rate of 1.5%. Because I want to extend this formula to other cells, I make the cell that is related to growth rate fixed. I put a $sign before the letter part of the cell and a $sign before the numeric part of the cell. So then click enter. So extend this till to the end of year 15. And after that, as it is mentioned in the question, the project beginning in year 16, the project is expected to begin generating cash flow of $3 million, and this cash flow grows at 1.5% indefinitely. So because it is indefinitely, it means that you have a perpetuity. And because the cash flow in this perpetuity grows, you have a growing perpetuity. So let's see what we have here. So cash flow that you have in year 16 is positive, and it is $3 million, and it grows at 1.5%. So multiply this one with 1 plus 1.5%, and you put a $sign before the cell to make it fix, the cell that is related to your growth rate. And then you can extend it to period future periods. So as you know, this growing cash flow goes to infinity. Here, just for an illustration, I think we are considering something like 400 periods, okay? So you can see that I generated the same cash flows for this project. Okay, so now we understand the structure of this project. So in fact, this project can be decomposed to three projects, three sub-projects. The first one contains is a growing annuity, right? So the growth rate is 1.5%. And it starts from -8 and then it increases, right? And then we have another growing annuity from year 6 till the end of year 15. And again, that one is a growing annuity because the number of periods is finite and you have a growth rate of 1.5%. And after that, you have a growing perpetuity that goes to infinity and cash flow grows at 1.5%. So in order to find the present value of this net present value of this project, you should find the present value of each of these sub-projects and then add them together. So let's do that here. So in order to find the present value for the first stream of cash flows that we have, we said that that stream of cash flows cover from year 1 to year 5. The first cash flow that we have is -$8 million and it will grow at 1.5%. And we know that discount rate is 9.6%. So let's find the present value of a growing annuity. We have the formula for present value of a growing annuity. So C is your first cash flow, so it's -$8 million divided by interest discount rate that you have minus the growth rate that you have. And then you multiply it with 1 minus 1 plus your growth rate G, which is 1.5%, divided by 1 plus your discount rate, which is 9.6%. And all of this should go to the power of t. So just pay attention that you consider parentheses that are correct. So just we send this to the number of periods that we have. We have 5 periods for this annuity, okay? And then we should click, we should make sure that the number of parentheses, so I should add another parenthesis. So then we should click enter. So as you see, this is the present value of your first annuity, first growing annuity. Then you have another growing annuity. That growing annuity starts in year 6. It starts in year 6 and it continues till the end of year 15. So let's use the same formula to find the present value. As I previously mentioned, whenever you use this formula to find the present value, it gives you value at one period before the first cash flow. So the first cash flow here is in year 6. The discount rate that we are using is an annual discount rate. So the present value that you find will be in year 5. So you should bring that value back to year 0. So let's do that. First, find the value, find the value of this growing annuity in year 5. In order to do that, divide your first cash flow with your discount rate minus growth rate. And then multiply it with 1 minus 1 plus your growth rate divided by 1 plus your discount rate. And then you should send this fraction to the power of number of periods that we have, which is here we have 10 periods, right? from year 6 to the end of the year 15. So we have 10 periods, and then you should close it and click enter. So this is the value in year 5. Let's bring it back for 5 years. In order to do that, just divide this whole value, present value in year 5, divided by 1 plus your discount rate to the power of periods that you want to bring back, which is 5, right? And then click enter. So you see, this is the present value in time 0. Then we have a perpetuity, and this perpetuity starts from year 16 and it grows, the cash flows grow at 1.5% to infinity. Present value of a perpetuity, of a growing perpetuity, as we mentioned before, is first cash flow divided by R minus G. R is your discount rate and G is the growth rate. So in order to find the present value of this perpetuity, divide 3 by your discount rate minus your growth rate. But again, this is value in period 15. So let's bring it back for 15 periods. Plus 1 plus your discount rate to the power of 15. To the power of 5 plus 10, 15. Okay. So you see, this is the present value of your growing perpetuity. Now, if you add all of these, sum all of these present values, you will get your net present value of your project, and then click enter. So you see, this net present value is exactly the same as what we have. So you found the net present value $2.98 million. Now we want to find internal rate of return for this project. Okay, so in order, because the number of cash flows that we have here it goes to infinity, we have a perpetuity. So in order to find internal rate of return, I want to use the goal-seek function in Excel. In order to do that, as you know, first you should define NPV function in a separate cell. Okay, so choose exactly. In order here to find the NPV, I added the formulas that we have in cells L. Let me see. The formula that you have in cell L8, this is the present value of your first growing annuity. I add this formula to the formula for the present value of the second growing annuity, and then I add the formula for the last growing perpetuity. So this cell of a V11 contains the summation of the 3 formulas that I use in order to find the present value of these 3 sub-projects. Okay, so we add them together. The only difference here is that instead of using the discount rate of 9.6%, whenever I see the cell L5, I replace it with the cell in which I want to find my internal rate of return. So I replace that cell with T11. Okay, you can see that I have T11 as my discount rate in this formula. Okay, after doing that, I click enter. I insert an initial value for my internal rate of return. As you know, internal rate of return is a discount rate that makes your net present value equal to 0. So it is the rate of return on a project. So I insert here, for example, 2%. You can insert, for example, 5%, whatever you want. Then you should go to the tab data, choose what if analysis, then you choose goal seek. Okay, In goal-seek function, I ask goal-seek to set the cell that includes my NPV equal to 0. So let's choose the cell that includes the formula for NPV. And I ask to set it equal to 0 by changing what? By changing the cell that contains my interest rate or discount rate, right? And then I click OK. And you see that Excel does all the calculation for you, and it makes NPV equal to 0 and gives you the interest rate that makes NPV 0, which is 10.45%. And this is in fact your internal rate of return, because it makes your NPV equal to 0. Then you click OK and you accept this result. So you found internal rate of return for this project, which is 10.45%. Later, if someone asks you whether you invest in this project or not, first, because the NPV of project is positive, you should invest in this project if your cost of capital is 9.6%. So if the cost of capital or your required rate of return on a project is 9.6%, you should invest in this project because this project has positive NPV. In other words, because your internal rate of return is higher than the required rate of return of 9.6%, then you should invest in this project. Okay, thank you very much and bye.